Alright, perhaps we just need some work a little bit with even and odd numbers. And just playing with those numbers a little bit and looking at the proofs. So one example that we did throughout the semester is if I had an even number plus an even number, I want to know what that's going to be. So to start with, I'm just going to do some practice and say like, well, if I had 2 plus 4, that's 6. If I had 8 plus 30, that's 38. Okay? It looks, just from a couple examples, and we could do a lot more, it looks like when I take an even number times an even number, I'm going to get an even number. I'm sorry, when I add an even number and an even number, the sum of the two numbers is going to be even. Well, let's look at how to prove that, okay? Our book did two things. One, we did a pictorial proof. So an even number means that we are taking some number, whatever it is, and we are multiplying it by 2. So see how this is nicely split into two parts? I don't know how long it is. That's what these dots in the middle mean. Could go on forever. I don't know. I don't know if this is 2 or 4 or 400. I just know it's an even number because there are two parts to it. Okay, and that 2 divides into it evenly. So then my job is I'm taking an even number plus an even number. So I'm going to grab another even number. And I'm going to make this one look a little bit different. Okay. But again, I don't know how big it is. But I can see that there are, again, two equal parts. Now, if I'm going to show that an even number plus an even number is even, I'm going to redraw this. Here's my first one. And my second one. Okay, now they've been connected by addition. Sorry, this one rectangle got a little bit fancy, didn't he? He kind of got some curves on him. Okay, so we've got two even numbers added together, and we can see that I put them together so they made a nice little rectangle here. Okay, now notice that I still have two equal parts. So here, if I take the top half of this, it is exactly the same as the bottom half. So an even number means we're multiplying something by 2, or we have two pieces exactly the same. So this is even. Okay. Another option for us is to talk about it algebraically. Okay. If I look at every even number is a multiple of 2. So I could call that 2k, where k is some number. I can, whatever I want to multiply by. Like if k is 7, 2 times 7 is 14. That's an even number. Okay? So if I have one even number, 2k, and I have a different even number, I'll call it 2m, and I add those two together, I can see that they both have a common factor of 2. So I factor out that common factor of 2, and I have 2 times something. Well, 2 times something is going to be an even number. So therefore, this is also even. Now I'm saying a lot of words here. So when you do this, you would need to write some words. Like, this is an even number. Okay, this is the sum of two numbers. Then, because I'm multiplying by 2, then the product is even. Obviously, we're talking about a sum, the product of those two, but since I factored out a 2, then the sum is even. Now, you can do the same thing with odd numbers. If I'm going to draw an odd number, 1, 3, 5, 7, 9, and I take two odd numbers, 3 plus 5 is 8, 5 plus 9 is 14. I'm just going to make a guess that says odd plus odd equals even. Okay, so pictorially, if we think about these odd numbers, and any odd number, is 2 times something. So like if I think about 3, 3 could be 2 times something plus 1 left over. 5 is 2 times 2 plus 1 left over. 7 is 2 times 3 plus 1 left over. So I have one little extra one in there. It doesn't divide out evenly. I've got this extra little remainder, which is 1, because it's an odd number. And then I'm going to take another odd number. And again, I will make it look a little bit different, just so we recognize that we're taking 2 different odd numbers, and I don't know what size they are. And he's got a little remainder on the end because he is an odd number. It's not evenly divisible. This part is evenly divisible, but if you take any odd number and divide by 2, you are going to get a remainder of 1. Now, when I add these together, I'm going to draw this one again. Okay, and then I'm going to take the other one and I'm going to make him fit in here. So I'm going to turn it upside down, do a little rotation on it. Okay, now look how it fits together so nicely. Now it makes a nice rectangle. There's no overlap. There's not something hanging off the edge anymore. And if I were to split it, I would have one part on the top and one part on the bottom that looks exactly the same, okay? Therefore, it's even. Now, we said that every odd number, when you divide it by 2, you're going to have a remainder of 1. So every odd number can be written 2k plus 1. So if I take a different odd number, 2m plus 1, and I add these together, I get 2k plus 2m plus 2. Now, we already proved that the sum of even numbers is even, so therefore this is even. Or I could factor out a 2 out of everything and show I have k plus m plus 1. So I have 2 times anything is an even number. 2 times anything is even. Alright, so those are 2 examples of proofs. You should be able to do the same thing with subtraction, odd and even numbers, the sum of odd and even numbers, the product of odd and even numbers, or odd and odd, even and even, and so forth. All of those should be possibilities for you to practice with.